Hello everyone, my name is Moss and today I will explain about Harvard MIT math tournaments. So let's see the problem. Let ABC be an equilateral triangle with side length 2 that is inscribed in a circle omega. A chord of omega passes through the midpoints of sides AB and AC. So we need to compute the length of this chord. First of all, I will draw the triangle. And then it is inscribed in a circle like this. I will write this as A, B, and C. There's a chord that passes the midpoint of AB and AC. So let M is a midpoint of AB and N is a midpoint of AC. And then we write the chord like this. Okay, we know that AM and MB is equal. So it is 1. AN equal with NC in equal with 1. And yeah, we don't forget to write the center of circle O. And we notice that in equilateral triangle we can write the perpendicular imaginary line. We also notice that this is similar between AM and, let's say, P. AMP is similar with ABQ. Okay, right. So now we can compute AQ and also AP. AQ over AB is sin 60 degree. It is equal with a half times root of 3. AB is 2, so we get that AQ is root of 3. We also know that AMP and ABQ is similar, so AP over AQ equal with AM over AB. It is half, and AP over root of 3, so we get AP is a half times root of 3. AB is a half times root of 3, so PQ is also same with AP, right? Yeah, for now we need to compute the radius of the circle. We can use this formula. Radius is ABC over 4 times the area of the circle. ABC is AB times BC times AC, so it is equal with 2 to the 3 over 4 times It is AQ times BZ over 2. So we get AQ is root of 3 times BC is also 2. And in this side, it is 2 over 3, right? So we get that the radius is 2 over root of 3, or we can say the radius is 2 times root of 3 over 3. Notice that AO is a radius, and from AO we can compute PO. PO is equal with AO minus AP. So it is 2 times root of 3 over 3 minus a half times root of 3. We will get that PO is equal with 1 over 6 times root of 3. Right? It is a half times root of 3. For now, if we want to compute this chord, right, we can draw an imaginary line again. We also notice that this is perpendicular between AQ and the chord, and we notice that this is a radius, right? Okay, so the chord, let's say x is 2 times root of the radius square minus PO square. It is 2 times root of 3 over 3 square minus 1 over 6 times root of 3. It is 4 over 3 minus 3 over 30. So we get that the x is 2 times root of 48 minus 3 over 36. We get that the chord is 2 times root of 45 over 6. So the root of 45 is equal with 3 times root of 5. So the x, the length of the chord, is root of 5. This is the final answer.